That is option B is correct. Question is identify the feedback of the circuit shown below. Okay, so this is the capacitance if we indicate with C. Suppose if it is not there, then the voltage which is developing across the resistor reverse biases the input diode. Okay, hence in order to get the same current we have to increase the V1 because the diode is getting reverse bias because of the potential developing across the resistor. But because of the capacitor which is shunting across the resistor, in case of an AC point of view, the capacitor is going to act as a short circuit which is going to be short the resistor. Hence there is no feedback because it is unable to develop the voltage across the emitter resistor because it is shorting with the capacitor. Hence the voltage across the emitter resistor is going to be 0. Okay, VE is equals to 0. That is, if I am indicating this node potential is VE in AC, because capacitor, that is XC, is 0. That is, AC point of view it is 0, means C is almost assuming that it is very large. Okay, hence option D is correct. Here the question is number of machine cycles required for LHLD instruction. See, before getting into the question, we need to know what do you mean by the machine cycle. Here, machine cycle means either reading or the writing the data into or from the memory. That is nothing but a machine cycle. Here, LHLD address. In case of, that is, this is the instruction in 8085 microprocessor. Address is nothing but a 16-bit data. Means the number of machine cycles are, first of all, upcode fetch means LHLD, that is upcode fetch. First machine cycle is upcode fetch. Second two machine cycles are reading the data from the memory because we are writing this instruction in the memory itself. So it is memory read and the memory read. And next we are loading the data from the memory, that is here this 16, the contents of the 16-bit data we are loading into the H register, and 16-bit address plus 1 into the L register, means there are 2 more memory reads. Hence there are 5 machine cycles are required in order to execute the LHLD instruction. Hence option A is correct. Is characteristic equation of an SR flip-flop. Okay, SR flip-flop. See here, characteristic equation is nothing but an equation for the next state in terms of the present state as well as the input conditions, present input conditions. So for an SR flip-flop, SR QN QN plus 1. If it is 0 0 0 0 0 1 0 1 1 0 1 0 1 1 1 1. See, whenever S and R both are 0, the output possible conditions for the output are 0 1, here also 0 1, here also 0 1, here also 0. If both are zeros, it is 0. If both are zeros, it is also 0 1. Means previous state remained as it is. If reset means it is both are zeros, whatever may be the previous state. If the set input is 1, irrespective of the previous state, the output becomes 1. Okay, if both S and R equals to 1, this nothing but a don't care condition. So if we solve the K map in terms of the previous state as well as the present input combinations, zero one 0 0 1 1 don't care conditions, this we can combine and this we can combine. So Qn plus 1 is nothing but R bar Qn plus S. Hence option A is correct. Is Closed loop transfer function of the unity feedback system is shown below. Find its type and order. Here the type means the number of poles at the origin in case of an open loop transfer function. Means for we have to decide the type and order from the open loop transfer function. Okay, order is number of poles, type is number of poles at the origin. Here first of all, this is the closed loop transfer function. We have to derive open loop transfer function. Closed loop transfer function is nothing but g of s by 1 plus g of s in case of unity feedback system. Okay, which is s by 2s plus 1. From this we have to get open loop transfer function, that is g of s is nothing but s by s plus 1. So if we simplify this particular equation, we will get this. So the number of poles at the origin is 0. That's why it is a type 0 system. Now the number of poles, non-zero poles are, the number of poles are here 1 itself. Hence type 0 and order 1 system, that is option C is correct. The question is, the dynamic response of a system is very weak, then the controller required to make the reliable system is. So here, if we want to improve the speed of the system, that means we have to decrease the rise time of a system. That is done by proportional derivative controller. Here in the question itself is mentioned here is that only we have to improve the dynamic response. There is no concern about the stability of the system. Hence we have to use proportional derivative controller. Option B is correct.